Greetings, this is Derek Ong with the continuation of the series of SmartPLS using SmartPLS for um, statistical analysis of complex models as well as for researchers who wants to use SmartPLS for their research. Now, in the preceding video, I mentioned something about common method variance, which is a problem which a lot of uh, top tier journals as well as universities would want their researchers to look into um, and how these researchers have overcome this problem of common meta variance. So before I mentioned about the Harman single factor test and some procedural methods which can be used, but if you use Harman single factor test only after you have collected your data, then it may not be well accepted in more uh, higher journals and more top tier universities. So you can check with your university and the journal in question to see if you can still get away with Harman single factor test. In this video, I'm going to concentrate on more um, higher level statistical remedies, some of which may work, some of which may not work, but then again, miracles do happen, so I'm just going to show it to you. The first one is using the partial correlation method, the EFA, saving the factor scores and then pointing it onto the dependent variable and comparing the R-square order beta. And after, it should not be different too much. And this is what we call the unmeasured marker variable. This is only used if, let's say, you have already collected your data. But I must warn you that most of the time this would not work because sometimes if there is already CMV inherent in the data, then it can show again. But again, like I said, miracles do happen, so we will see. The other method that you can use is before you collect your data, use a social desirability scale by Fisher and Fick. Probably certain questions which are totally unrelated to the research that you can put into the questionnaire, and it can help you to find the CMV in your data if there is any CMV, and then you run it, and then you can pick the correlation method. Again, any correlation more than 0.3 between the marker variable and the principal constructs, then it's problematic. Now, you can either use that or you can use the measured latent marker variable, which is where your social desirability scale come in and point it at both independent and dependent variable, and then compare the beta or the R square again. And of course, I would say compare the R square, which is a little bit more easier to look at the differences. Anything differences more than 10%, then you know that there is a problem. So, in case you want to find out where the social desirability scale is, I actually have one here. Uh, and you can find it online. Yeah, the social desirability scale actually was started by this Marlowe and Crown, but then again, you can just put in any of these scales inside just to give it a little bit of difference in your questionnaire. Now, assuming that you don't have this scale, so I'm just going to show it to you what you can do. Okay, this is our data set, of course, and you notice that we have SD1, 2, and 3 as the social desirability scale. Now I'm going to show you how to do the unmeasured marker variables. So we assume that these three are not here first. Let's start with the analyze and dimension reduction to factor. Reset this. Now, every single factor goes in, every single item except the social desirability scale. Like I said, imagine they're not there. The extraction, we're just going to use the principal access factoring because of latent variables. We're allowing it to just run, so we're not forcing into one factor. The rotation is Varimax, unlike the Harman single factor where we just leave it unrotated. And then we're saving the scores. The most important thing, we need to save the scores here. After you press OK, you notice that it will extract 7 factors but we're not so concerned about factor 2 up to factor 7, and we're going to just delete that. We are more concerned about the first factor because we want to see how the first factor would affect in terms of CMV. And we're going to call this the unmeasured marker, right? Save this as an unmeasured marker, and we're going to call it adopt2. So I'm basically showing you how to use unmeasured marker, which is the factor score, and the measured marker in the same data set. Now, in most cases, you might have it separately, but I'll just show it to you so that you can understand what I mean here. To be easier. So save. And what you need to do now is you have to insert a new data set inside. So import a new data file called adopt2 and let the adopt2 be the new data file that it uses. Alright, so make sure that this data file is active, and we are going to run this data. Okay, so first thing you want to do is you might want to just copy this the R square 0.335 and 0.212 into your Microsoft Word so that you can make some comparisons. So what I'm going to do is I'm going to copy this file, export image to clipboard, and I'm going to save it under a section where I'm just going to write there common method variants. Okay, so there, I have that here, and this is without the measure marker. Okay, without the measure marker, we are going to put in the R square, and you notice that I've written the R square here without the measure marker as 335, the technology adoption, and for financial performance as 0.212. Now we're just going to put in with the measure marker, and then we see what happens. All right, so that we can compare the two. So the measured marker is a single indicator. So what we're going to do is we are going to place it in as a DV. Right. So again, make this and call this as measure marker, unmeasured marker, call this unmeasured marker, and we are going to connect these two, and notice that they're red, so we got to put in the reflective and as well as this one. Okay, right, since the name needs to be unique, so we make sure to put this unmeasured marker. We can put this as TA, and we can put this as FP. Alright, so now we run the PLS algorithm, and notice how the thing changes. 0.344 and 0.215. Yep, 0.344 and 0.215. Right? So this is how we check. If you notice that's not much changes, if it's less than 10%, so you notice that the CMV is not a problem. But if let's say we can use the measured marker, which what I'm going to do now is the SD1 and 2 and 3. So I'm going to take this out. I'm going to put it to in 2. This is checking the social desirability. So SD social desirability 1. This will be, oops, sorry. Thank God I can undo. This will be social desirability 2. Desirability 2. Now, all I need to do is put in the SD1, 2, and 3 onto each one. Connect into both. And then we now compare the R square again. And as you can see, in terms of the R square, again, it is not so different. So these are your two types that you can do when R square change 217 and 338. So you have 217 and sorry, this is 217 and 338. So there is your difference comparing the R square change. If it's not high, you should collect your measure marker variable first to avoid CMV. But this is just to show you how different the thing can be when you do your CMV. Now, like I said, you could either look at the R square, or you can do another table and do the comparisons of your beta, whereby you will have to put in the social desirability on each and every one of the independent variable, but that will be a lot of work. So it's better to just compare the R square for now. Alright, if you have any questions on this, please email me, or else thank you, and do note to remember to collect this note here. Moral of the story, before you collect your data, collect your measure marker variable first. Use the social desirability scale. Just a few questions will do, you don't have to do a lot. Alright, thank you very much. please continue to watch the videos for more updates on the analysis.